Hey everybody, in this video we are going to be continuing with the rest of the examples in the Module 3 notes. So we'll just start and pick back up where we left off. We were on B7. So in this question we're being asked about converting from teaspoons to gallons. Now we're also given a couple of other conversion factors that are just common knowledge. We may need these, we may not need them, it just depends on what we have in the question. We do need to get from gallons to teaspoons, and we need to kind of find a connection between gallons and milliliters here to be able to make the connection from gallons to teaspoons. Our ultimate goal is to convert gallons into milliliters and then milliliters to teaspoons. This conversion factor here, quarts, the quarts and gallons, we're not really sure if we need that one because we don't see quarts anywhere else in this problem. But we do know at least somewhat of a roadmap is to get from gallons to milliliters to teaspoons. Possibly in between there, we might need to convert to liters at some point and then get to teaspoons. So let's see if we have some conversion factors in our formula chart. One of the ones that we used earlier was that we know that 1,000 milliliters is equal to 1 liter. So that allows us to kind of make a connection here between liters and milliliters. If we refer to our formula chart here, when we think about gallons, the only conversion factor that has gallons here is this one. 1 gallon is equal to 3.79 liters. So we may possibly need that conversion factor as well, that 1 gallon is equal to 3.79 liters. And then what I've highlighted in green is that 5 milliliters is equal to 1 teaspoon. So as you can see here, we have our factors. You have gallons, we also have liters, we have milliliters, and it kind of, loops around and we end up at teaspoons. So we're kind of trying to piece this conversion chart together, or this dimensional analysis chart, over a few different columns. We definitely want to start with 1 gallon and now start working towards teaspoons. So remember that we always want the next column to match the previous one in the denominator. And we know that from our conversion factors that 1 gallon is equal to 3.79 liters. That's this conversion factor here, so we can cross off our gallons. Then we know that we need to move to the next column, and we see we have liters here. So it looks like we can put 1 liter is equivalent to 1,000 milliliters. So that takes care of the next conversion. And then we have 5 milliliters is equivalent to 1 teaspoon. We can cross off our milliliters. Similar to before, we're going to multiply across the top, the numerators and the denominators. And this should end up giving us 3,790 over 5 times 1 times 1 is 5. We divide that again, and you should end up getting 758 teaspoons. So there's B7. Let's look at B8. B8 is talking about seconds converted from 3 days. So it says how many seconds are in 3 days. These conversion factors are more commonly known because we frequently read the time and we know how time works. We know that we need to get from days to seconds, but there's a lot of other ways to measure in between days and seconds. For example, We know that one day is commonly thought of as 24 hours. We know that 1 hour is commonly thought of as 60 minutes. And as we continue to break this down, 1 minute is commonly thought of as 60 seconds. So there's a few conversion factors that we already commonly know that help us make this conversion to go from 3 days. Our next column will be 1 day is 24 hours. And we want to continue to break this all down until we end up at seconds. So we know that 1 hour is 60 minutes. And we know that 1 minute is 60 seconds. So it looks like we have all of our units cancel here, hours and hours, minutes and minutes, and we're ending up at seconds, which is what we want. After you make this conversion, you should end up across the top multiplying to get 270,000. Across the bottoms, it's all ones, so we can just leave this as 270,000 seconds. Let's take a look at section C now. Section C has various examples that involve dosage calculations, flow rate, IV flow rate calculations, and things like that. So C1 is asking us to determine a flow rate, and our answer should be in drops per minute for the given IV, where we assume that there's a drop factor of 15 drops per milliliter. And this boxed information right here, that's kind of like what the order is or what the prescription says. 1,800 milliliters needs to be given through IV in 6 hours. So this follows a lot of the same things that we've looked at in the previous examples. There's just a couple of smaller pieces to it. So the first thing is that we want to write as many conversion factors as we know so far. So we know that in this situation, 15 drops is equal to 1 milliliter. If you've ever seen an IV bag, you can see the drops falling. 15 of them is equivalent to 1 milliliter. We can also write our prescription also as one of our conversion factors, that 1,800 milliliters needs to be equivalent technically to 6 hours of time, or it needs to occur in the 6 hours. And then we want to find a connection between hours to minutes, because this right here, although there's no numbers, you see drops per minute or drops/minutes. That indicates to us that we need to somehow convert to minutes. Right now we have hours, so we know that 1 hour is equal to 60 minutes. So let's see if this is enough for us to determine what to do here. When we start off, we're always going to start with the order. And when we start with the order, that's this right here, the 1,806 hours. We can place the 1,800 milliliters up here, and we can place the 6 hours right below it. Before, we were keeping this box blank because we were just going to be converting an amount, but now we need an amount per time period. So that bottom space is optional, but in this case for flow rates, you can place the time or amount of time in there. We're still going to follow the same pattern though. We had milliliters up here, so we want to place milliliters in the denominator of the next one. And we know that the flow rate, the drop factor, sorry, is 1 milliliter is equivalent to 15 drops. We got that from this first one right here. So our milliliters cancel. We also used that one. So the only one that's left is this right here. Now we see though that we have drops here, and we might be thinking, okay, we want drops down here because that's what the pattern we've been following. Now with dosage calculations, that's not always going to be the case. We actually want our answer to be drops, but we want it to be per minute. Right now, if we were to finish the problem, it would be drops per hour because we haven't canceled out the hours. So now what we want to think here is, how do we place this conversion factor here? Well, we already see that we have hours down here. So that means that we need to place the same unit up here in order for that unit to cancel. 1 hour is equivalent to 60 minutes. This allows for the hours and the hours to cancel. So this not only shows you that they cancel, but this teaches us that you don't need for the hours to be right next to each other in the entire chart. They can be anywhere as long as one of those units is across the top somewhere and one is in the bottom. They can be separated like this though, and they'll cancel just like we cancel milliliters, milliliters. And now what do we have left? We have left drops over minutes, which is what we wanted. The question said, find the flow rate in drops per minute. This is what we wanted. We don't want the green here drops per minute to cancel. We want to keep those. So now let's follow the process and multiply across the top and the bottom. When you multiply across the top, you should end up getting 27,000. Across the bottom, you should end up getting 360. And when you divide those two numbers, you end up getting the number of 75. Now in this case, the unit is going to be drops per minute, 75 drops per minute. So when you're thinking about a real situation, if the order says to do 1800 milliliters in 6 hours, and this is your drip factor, then that means you need to set the machine to do 75 drops per minute in order for this to complete perfectly in 6 hours or close to 6 hours. Let's try another example. C2 is also a situation that involves an IV. It's asking find the length and time instead. So our answer is going to be in hours at the very end. We have a drop factor this time of 10 drops per milliliter. So 10 drops equals 1 milliliter. We also see this 50 drops per minute. 50 drops equals 1 minute. We also see that we need to go from minutes to hours. So it's not explicitly written, but we know that 60 minutes is 1 hour. This one commonly shows up. So now just setting this up, we want to see how long it takes 1,000 milliliters. How much time in hours will it take for this 1,000 milliliters to be completed? So we just follow the process. We're going to take 1 milliliter here, and we're going to say that's 10 drops right above it. Then we're going to say, okay, 50 drops down here. Above it is going to go 1 minute. So that takes care of our drops. Then we have 60 minutes is equivalent to 1 hour. So the minutes cancel here. And this time everything canceled except for hours, which is what we want our answer to finish in. So multiplying across the top, you should get 10,000 when you multiply. Across the bottom, you should end up getting 3,000. So this roughly is about 3.33 hours, or depending on the question, you're thinking 3 1/3 hours. But more commonly, we usually say that's 3 hours and 1/3 is just the same thing as 20 minutes. So depending on the question, you may see any of these versions as well, but it's 3.33 hours. Okay, let's look at a couple of examples that involve a patient getting a medication based on their weight. So this question says that a patient needs 50 milligrams per kilogram that they weigh. How many grams must they get if they weigh 180 pounds? So listing out our conversion factors here, first off, the 50 milligrams is per 1 kilogram that they weigh. We also see that there's grams and milligrams. So we know that 1,000 milligrams is equal to 1 gram. And lastly, we see we have pounds. The most common conversion factor you'll see with pounds is that 2.2 pounds is equivalent to 1 kilogram. You can also find this weight conversion in the conversion chart here. We see that 2.2 pounds is equal to 1 kilogram. So some of these will be in your formula chart, and some of them you'll have to memorize, like the milligrams to grams conversion. Now, when we do a weight conversion for medication, we're always going to start with the patient's weight. So 180 pounds. And now we just follow our process and steps. And we're going to now find whatever conversion factor has pounds in it, and we're going to place that in the next column at the bottom. 2.2 pounds is equal to 1 kilogram. And we just keep following the trail of units here. We see kilograms here, so that's going to be our next unit. 1 kilogram per 50 milligrams of medication. We can, if you want, mark off your units as you go. Our last conversion here should be 1,000 milligrams is equivalent to 1 gram, because the question asked us how many grams should we give. So we see grams there at the end, and that's good. We multiply across the top and the bottom, we end up getting 9,000 over 2,200. So we get 4.091 roughly, and that's in grams. So since this patient weighed 180 pounds, that converted all the way to telling us that the patient needs to get about a little bit over 4 grams of this medication. So for C4, I'm going to set you up with the conversion factors and see if you can try to determine your solution there. So looking at this, we've got a few different conversion factors. The patient weighs 150 pounds. They require 250 milligrams per kilogram. It says the medication is available in a concentrated solution of 7 grams per milliliter. How many teaspoons should be administered? We're given that for teaspoons, it's equal to 5 milliliters. So let's list out these conversion factors. 250 milligrams equals or is equivalent to 1 kilogram of the patient's weight. Then we have 7 grams is equal to 1 milliliter. That's the second conversion factor. And this third one is written right there. I'll just rewrite it down here so it's in our list, 5 milliliters equals 1 kilogram. Whenever we're dealing with the patient's weight, usually it's going to be in pounds, so we want to convert that to kilograms. So we're going to need to also remember that 2.2 pounds of the patient's weight is equivalent to 1 kilogram. And notice how you also have milligrams and grams, right? We need a connection between the milligrams and the grams, and that's going to be the milligrams to grams conversion factor. 1,000 milligrams is equal to 1 gram. So see if you can take those 5 conversion factors and determine the amount in teaspoons that this patient should get if they weigh 155 pounds. So there's the setup. See if you can figure out what goes in the next column and keep building after that. You can check the key after to compare your solution to see if you got the right answer. For C5, it's also weight dependent. So let's walk through, and this time I'm gonna, even give you a little bit less to see if you can test yourself a little bit. In this one, it says the patient weighs 66 pounds. Here's how much medication they need, 45 milligrams per kilogram of their weight. It says that the medication is available in a concentration of this solution right here, 125 milligrams per milliliter. How many milliliters do they need? So see if you can try to piece it together. There are a few ones that aren't listed here, a few conversion factors not listed that you would need to determine this conversion. But see if you can pause and try this one on your own and then compare with the key. Let's try C6 together. So this one says that a patient requires 0.5 grams of a medication, and it's available to them in 250 milligrams per milliliter. This is likely a liquid where it says 250 milligrams per milliliter. So if it's available to us in this liquid, we need to know how much of that liquid to give the patient. If they're only supposed to get 0.5 grams, how many milliliters does that mean? And we need to go from grams to milligrams as well here. So we see that we need this conversion, 1,000 milligrams is equal to 1 gram. So let's see if we can set this one up. This time it's not a patient weight, it's just a flat number of grams that they need, 0.5 grams. And we need to determine how many milliliters is this. Looking at our conversion factors, we need grams in the next column, most likely. There it is. 1 gram is the same thing as 1,000 milligrams. That takes care of the grams. And now, going from milligrams, we know that we have milligrams right here as well, so we could use this one. 250 milligrams would go down here, and 1 milliliter would go up here. So our milligrams cancel. And now we've ended up with milliliters here, and that's good because we need to know how many milliliters do we need. So we're just going to finish this problem by multiplying straight across. When you do this, you should get 500 on the top and 250 across the bottom. You divide that and you end up getting 2. The patient needs 2 milliliters if they're going to get 0.5 grams of the medication. Okay, so that completes section C of the notes. If you have any further questions about any of these examples, please feel free to email me and let me know.